Okay? And so when you look at the latitude of a city, okay, the way that latitude is expressed is it identifies these parallel lines that exist on kind of an overlay of the Earth, okay, where the equator is 0. And if you picture this side view of the Earth, a latitude simply means that the city is located in such a manner that if from this side view you connect the location of that city back to the center of the Earth, the angle that's formed there with the equator is going to be the latitude measurement. So that means that this central angle right here at a latitude of 30 degrees would be 30. The latitude of 60 degrees means this central angle that's formed here is going to be 60 degrees. These are also called parallels. So a latitude of 30 degrees means it lies on the 30th parallel, 60th parallel. Has anybody ever paid attention to the signs on I-5 when you drive by Salem? There's a sign on the side of the highway that says this is the 45th parallel. You're now crossing the 45th parallel. That means that that location is halfway between the equator and the North Pole. And so that's where that location near Salem is the 45th parallel. And it means that the central angle that would have been formed there with the equator is 45 degrees. So the way that, and then again, of course, the North Pole will be up here at 90 degrees. And so here's what the type of questions that are going to be given involving latitude or the parallels. It'll specifically ask you how far or at what distance along the Earth is a city, let's say, on the 30th parallel to the equator. What is that distance? And so the distance traveled along the Earth is a curved path. It's not a straight one. And so you can use this calculation of arc length to find that distance. So if we were finding the distance from a city on the 30th parallel to the equator, we would say use the arc length equation is equal to m over 360 times, and again, depending on whether you're given an arc length or the information of circumference, you'll use this form of the equation. If you're given the information of radius, you'll use 2 pi r instead of circumference. And finally, if you're given the diameter, you'll use m over 360 times d pi. So again, these are the three equations depending on the information provided. One of the more common ones is going to be 40,000 kilometers. It's a nice approximation with easy to work with numbers. Yeah, I'll always give you this information. You don't have to write it down or anything. Right, so let's say we wanted to find that distance, and they would assume, let's assume the circumference. So if you want to find what is the distance from a city on the 30th parallel to the equator, we take our m value as this central angle measure, 30 degrees, over 360 times c, which we would use 40,000. And so we could calculate that distance along the Earth's surface. And now here's where the kind of tricky part is, and the part that gets students in trouble. And that is, you're probably either going to be asked, the majority of the time you'll be asked to find the distance to the equator or the distance to the North Pole. And when you're asked, or students are asked distance to the North Pole, it becomes a trickier problem unless you kind of sketch it out. If you sketch it out, it makes perfect sense. And so what is the central angle? Now, if we wanted to find the distance from a city on the 30th parallel to the North Pole, what would our arc measure be? Yeah, so now it's 60 degrees, right? It's the difference between 90 degrees and whatever that latitude measurement is. So 60 over 360 times the 40,000 would give us the distance from that city to the North Pole. Just make sure that you're very careful, that you're reading the problem and understand what it is that it's asking you to find.